The basic quadratic is y equals the square of x. The most general quadratic expression has standard form and vertex form. The vertex form can be transformed into standard form as an example. 2 times the square of x minus 3 then plus 7 equals 2 times the square of x then minus 12 times x then plus 25. Here is the quadratic graphs. The first one is basic quadratic graph. In the second graph, if h is less than 0, the shift is to the right by negative h. In the third graph, if a is less than 0, then the graph is inverted. In the last graph, if k is less than 0, the graph is shifted down by negative k more than 0.
Quadratic function may have 0 to 2 roots. To find the roots of a quadratic function, we will set f(x) equal to 0 hereby to solve the equation in both standard form and vertex form. In this example, 2.73 and negative 0.73 would be the x-intercept of the quadratic. On the other hand, we can better understand how to write a quadratic into standard form given the vertex form, and vice versa by completing the square. Use x minus 5 to the power of 2 as an example. Each square is representing different part of the equation. Next, group these small squares into a big square and multiply each side of the square. Sum that together. The standard form of this quadratic would be square of x plus 10x plus 25.
Okay, let's move on to factoring. Today in this video, I'm going to introduce a method called cross method of factorizing quadratics. So what it does is to make the equation y equal to ax squared plus bx plus c equal to blank x plus blank times blank x plus blank. So what we do is to find the factorization of a and c. So we let a equal to a1 plus a2 and c equal to c1 plus c2. Then we write a1 and a2 vertically under the ax squared and c1 and c2 under the c. And then we draw a line from a1 to c2 and also a2 to c1. And the key here is the b. We need to make sure b matches one of the 3 equations listed below. Let's take an example to better understanding this theory. So question 1, factorize 6x squared plus 13x minus 5. And then we factorize 6 to 1 times 6 or 2 times 3. Also the same thing for negative 5. It can be negative 5 times 1 or negative 1 times 5. Now we're ready for our first attempt. So this time we will try 1 and 6 with negative 5 and 1. And then we just cross our finger to hope the sum or the difference of the multiple will match with the b, which is 13 in this case. And it doesn't. But don't give up too early, we still have a lot of combinations to do. And finally, yeah, we got 13. From this point, we can rewrite our equation 6x squared plus 13x minus 5 equal to 2x minus 1 times 3x plus 5.
The last part of our topic is to talk about discriminant. When we look at a squared plus bx plus c equals 0, then we can use this quadratic formula to find the solution. But we don't know how many solutions, so that's why we have discriminant. Delta is, we call this side as a delta, and it is equal to b squared minus 4ac. The first situation of delta, when delta is greater than 0, then it should be 2 solutions. In this equation, delta is 49, that is greater than 0. So it should be 2 solutions. When we sub the quadratic formula, then we got these 2 separate solutions. It also shows in the graph, it has 2 solutions. So it's true. The second situation, when delta is equal to 0, it should be 1 solution. In this equation, delta is 0, so it should be 1 solution. When we sub the quadratic formula, and then we got these 2 same values of x solution, so that's why it's just 1 solution. And then in the graph, we also can see that it's just 1 point to touch at the x-axis, so that is just 1 solution. The third situation, when delta less than 0, it should be no solution. In this equation, delta is minus 27. It is less than 0, so that's why it's no solution. And then when we sub the quadratic formula, we got this solution. However, we can't negative a negative number as a real value, so that's why x is no solution, because it just got the complex number. So in this graph, we can see the graph do not touch the x-axis, so that's why it's no solution. That's all of our assignment video. Thank you.